Right, so let's look at one of the problems it's like one encounters with LU decomposition, which is what is called small pivots. So if you recall, it's like when you're doing LU decomposition, you do use elementary row operations to add sort of one of the rows it's like to the other rows in order to zero out some entries in the matrix. And the coefficient it's like which you you use it's like involves dividing it's like one of the entries in the matrix by one of the diagonal entries, okay? And that diagonal entry is what's called a pivot, okay? So let's look at what happens when that pivot, which you divide by, is small, okay? So this is the problem with small pivots. So let's look at it, this via means of an example. So I'm going to write down two equations and two unknowns, equation 1 and equation 2. Let's say 0.0030000 x1 plus 59.14 x2 is equal to 59.17. Okay, and then 5.291 x1 plus 6.130 x2 is equal to 46.78. And it's easy to convince yourself that the exact solution is that x1 is equal to 10 and x2 is equal to 1. So let's pretend I'm going to try to solve this system of equations using a computer that only stores 4 digits of accuracy. So I pretend to solve this system on a computer with 4 digits of accuracy. Okay, so the matrix A is just the coefficients which you see here. So I'm going to look at this entry L21, right, which is this coefficient divided by this coefficient, right? So that's 5.291 divided by 0.003. And the basic idea is that I want to add an appropriate multiple of the first equation to the second equation so that that coefficient vanishes. It gets zeroed out, right? So this is approximately 1764. Okay, so equation 2 gets mapped to equation 2 minus L21 equation 1. All right, so I'm left with 0.003 x1 plus 59.14 x2. I'm going to put a tilde here to represent the fact that this second equation is somehow been contaminated, if you will, by round-off error. Okay, so so in particular, x1 tilde and x2 tilde is not going to give me the same answer as this x1 and x2. Okay, as we'll see in a little bit. Okay, so this is 59.14. That's the first equation, and the second equation looks like minus 1043. And again, I'm only storing the first 4 digits, and I'm throwing the rest away. 00 x2 tilde is approximately equal to negative 104400. And then when you solve this using back substitution, you can check that x2 tilde is equal to 1.001 and x1 tilde is approximately equal to minus 10. So that's a very dramatic difference from this here. So x1 minus x1 tilde is 20. So this is a huge error, right? That's a 200% error. Okay, so that's not good. So the problem, as you might have guessed is that I'm dividing by this pivot, which is very close to 0. So the problem is that I'm dividing our pivot 0.003 is close to 0. And if you recall, when we were discussing round-off errors, one of the situations you really want to avoid in order to avoid round-off error is to avoid dividing by a very small number. Okay? And so in this situation, it's like we have that. So let's now look at the same problem, but now I'm going to switch equations 1 and equation 2, right? And in principle, nothing should happen, but you'll see that you'll get a very different, it's like sort of numerical answer when you do that. Okay, so I'm just going to do the same thing as before, but now I'm going to switch equations 1 and 2. So I'm just going to erase this thing here, right, and call that equation 1 now, right? So that was the same equation as before, and I'll copy down the old equation. So that's 0.003x1 plus 59.14x2 is equal to 59.17. And then as before, the answer is that x1 is equal to 10, x2 is equal to 1. Okay, all right, so now the pivot is this much bigger number, 5.291, right? So L21 is equal to 0.003 divided by 5.291, which is 0.0005670. So I'm just, again, as before, only sorting the first 4 digits. Okay, so that's approximately equal to. All right, and when you use that now, it's like, and you do this elementary row operation, it's like to zero out this entry, the equations you get are 5.291 x1 tilde plus 6.130 x2 tilde is 46.78 as before, and then you get 59.14 x2 tilde is approximately 59.14. Okay, and then if you do these calculations, then x1 tilde is 10, and x2 tilde is 1. And so that's quite dramatic, right? I mean, it's like, because of round off, the ordering of the equation ends up mattering, and the ordering of the equation ends up mattering because when I had swapped these rows, then what plays the role of this pivot, which is the thing which I'm dividing by, changes, right? So it changed from this entry, which is 0.003, which is very close to 0, to 5.291, which is a more sort of reasonable number to divide by. Okay, so that's a cautionary tale, if you will. So what is this process called? So switching rows before applying Gaussian elimination is called pivoting. Okay, so that's something it's like to observe that pivoting does matter. Okay, or this process of sort of potentially switching the equations around, it's like does matter. Okay, and we'll talk a little bit more about how to do this systematically. So let me just stop here for now.